Hello there, my name is Pliny Marco De Toni. I'm a psychology professor at the Midwestern State University in Brazil and the head of the Psychology of Bilingualism Lab. And today I'm going to show you guys how to draw and how to name all the sulci and gyri of the inferior view of the cerebrum. And we're going to start by showing a model of the brain. So that's the whole brain. Here we have the cerebellum down here in the back of the brainstem down here, divided in medulla oblongata, pons, and up here the midbrain, and that would be the cerebrum. But that would be the lateral view of the cerebrum, because of course when we analyze the cerebrum, we got to understand that we can do that through three different views. So that would be the lateral view. If we split the brain into two hemispheres and analyze this view here, that would be the median view. But today what we're going to do is analyze the cerebrum through this other view here. That is the inferior view of the cerebrum. So if we compare the model with this drawing here, we are going to see that there are some parts of the drawing that are actually hiding by the other parts of the brain. So for example, the cerebellum down here, or even the brainstem that are removed. So for us to get to this drawing, what we gotta do is remove the cerebellum. That's what I'm gonna do now. Remove the cerebellum and also the brainstem, that is this structure here, and then we're gonna get to this drawing. So I'm gonna also remove the brainstem here. Just a sec. Okay, one hemisphere. Now let's do the same with the other hemisphere. Oops. Here. And let's put the hemispheres together. Okay, so here we have the whole inferior view of the cerebrum. So if we compare the model with the drawing that I just made here, we're gonna see that we can analyze one hemisphere here. That would be this hemisphere. The other hemisphere is here, the other hemisphere, and we also can see three lobes out of the four lobes that we can usually see in the lateral view. Because the lateral view, we can see the frontal lobe here in the front, the parietal lobe up here, the occipital lobe in the back of the brain, and the temporal lobe on the sides of the brain. But when we turn this around and we analyze the inferior view of the brain, of course, like the parietal lobe that is up here, it's going to be in the back. So there is no way to see the parietal lobe here. We can see the frontal lobe, the frontal lobes from both hemispheres. So frontal lobe. So that would be the frontal lobe. Here on the side of the brains, on the sides of the brain, we can see the temporal lobe. So if that's the temporal lobe, if we turn it around, so that would be the temporal lobe. So here we have the temporal lobe, and here in the back, the occipital lobe, occipital lobes. So that would be the occipital lobe. So that's pretty much what we're gonna do today. So starting with this drawing, what I want to show you guys is how to draw the inferior view of the cerebrum. And I chose to use cerebrum instead of brain because I removed the other parts of the brain, just like I said before and I showed with the model. So I removed the cerebellum and the brainstem. So I just left the cerebrum. That's why it's the inferior view of the cerebrum and not the inferior view of the brain. And what I want to show you guys is how to name all the sulci and gyri of this structure. So we're going to start with the sulci. So let's just write it down here. Sulci. And just remembering that sulci is the plural form of sulcus. So we have one sulcus and all the sulci, two sulci. So that's the plural. So we're gonna analyze all the sulci here first. So I'm gonna just add some numbers here, and then we're gonna make a list of the sulci of this view. And just to remember that everything that we see on one hemisphere is actually the same on the other hemisphere. So I'm gonna just number the structures on one hemisphere, but it's exactly the same on the other one. So here we have 1, 2, 3, 4 sulci. So let's do it. 1, that would be this one here. 2, until here. Here, this one here is actually another sulcus, so 3. And this little one here, 4. So that would be the sulci that starts here in the occipital lobe and goes all the way to the temporal lobe. Other than that, we also have 2 more here in the frontal lobes. So we have this one here, so that would be 5. And we have a lot of sulci here that actually has, like they have the same names. So all of these sulci here, I'm gonna just put a 6. That's gonna represent all the sulci here, here and here. Like I said, it's the same. So let's start here by naming these sulci. So 1, 2, 3, 4, 5, 6. Okay. This one here, for us to remember some of the names, some of them are actually kind of complicated. You gotta memorize it. There is no other way. But some of them actually are pretty logical. So we just have to understand where they come from. So this one here, for example, it's the sulci that starts in the occipital lobe and goes all the way to the temporal lobe. So it's called occipital temporal sulcus. Occipital temporal sulcus. Okay, this one here is called collateral sulcus. And the collateral sulcus becomes the rhinal sulcus. That is the number 3. Rhinal sulcus. Okay, rhinal comes from smelling. So it's the olfactory functions that we're gonna end up seeing later on that are located here in this region. So rhinal sulcus. This one here, it's called calcarine sulcus. Calcarine sulcus. Calcarine sulcus. And it's actually one of the main regions of the brain related to visual sensation. So all the visual stimuli that we get out of the environment, they end up getting here around the calcarine sulcus in both hemispheres. So this is related to visual sensation. Okay, here we have another sulcus that is called olfactory sulcus. Olfactory sulcus. So we can imagine that on on top of this sulcus here, we have the olfactory nerve and then the olfactory tract that goes all the way to this region here. That is one of the regions related to smelling. Okay, olfactory sulcus. In all these sulci here, we have actually just one name for all these sulci that is called orbital sulci, or orbital sulci. Sulci because it's plural. So all these sulci here have the same name, orbital sulcus or orbital sulci, if we consider all of them. Okay, so that would be all the sulci of this inferior view of the cerebrum. Moving on, we are going to analyze now the gyri. So let's write here gyri. And gyri is the plural form of gyrus. Okay, so all the gyri of this view here. And in order to do that, I'm going to just keep adding numbers, but I'm going to use, just for us not to get too confused, I'm going to use this hemisphere here, okay, for the gyri. So that would be, so 6, so 7. Here we have one gyrus. 8, another gyrus. 9, that becomes 10. This is an imaginary line, so this is actually not a sulcus. So it's just an imaginary line, more or less located for us to separate these two gyri and also these two sulci here. So 9, 10, 11, this little one here, 11. Other than that, we have this gyrus here, 12. And we have a lot of gyri in the middle of the orbital sulci. So that would be 13. Okay, so that's pretty much it. So let's just name them. 7, 8, 9, 10, 11, 12, 13. All right. So this one here is actually the same gyrus that we can see when we analyze the lateral view of the cerebrum. So if we remember the lateral view that we saw on the previous video, so that would be the lateral view of the cerebrum. Here we have the central sulcus, lateral sulcus, parahippocampal sulcus, preoccipital notch. And here, and of course we have all the sulci and gyri, but I'm going to just focus on the temporal lobe here. So on the temporal lobe we have the superior temporal sulcus, inferior temporal sulcus, and this one here, this gyrus here, is called inferior temporal gyrus. But the thing is that this gyrus goes around the brain up to the inferior view. So it's the same here. So if you imagine this, let me just get the model here. I think it's easier to show it. So if we get, for example, down here, we have the inferior temporal gyrus. I'm going to just hold it and turn it around. And then you guys are going to see that it's the same gyrus that we have here. This first one, number 7. So that's also called inferior temporal gyrus. Inferior temporal gyrus. Okay. This one here, number 8 and number 9, they have pretty much the same name. In English, actually, there are two ways to name these gyri. One of the names is actually because it goes from all the way from the occipital lobe to the temporal lobe, so it's called occipital-temporal gyrus. But since there are two of them, that would be the lateral and that would be the medial. So lateral and medial. Occipital-temporal gyrus. So that would be the lateral occipital temporal gyrus, lateral occipital temporal gyrus, and this one here, it's the medial occipital temporal gyrus. That's one way to name these structures. Another name that is very common actually in English is calling these two gyrus by two other names. So we have, so I'm going to just repeat here, 8 and 9. 8 and 9, these two here. So this one here would be, 8 would be the fusiform gyrus, and 9 would be the lingual gyrus. Fusiform gyrus and lingual gyrus. And I'm not totally sure about that, but I feel like in English people tend to use more these two names here, fusiform gyrus and lingual gyrus, than these two here. In Portuguese, we use just pretty much these two ways to name these two gyri, lateral and medial occipital temporal gyri in this case. But in English, I feel like they use these two names more than these ones here. Okay, so the lingual gyrus becomes the parahippocampal gyrus. That is number 10. So parahippocampal gyrus. Parahippocampal gyrus. And why does this structure have this name? Because here we actually can find the hippocampus. One hippocampus here and the other hippocampus around here. So it's the parahippocampal gyrus, which means that it's the gyrus that is besides the hippocampus, parahippocampal. That's why this name. Okay, so here we have another one that is called isthmus of cingulate gyrus, like this, isthmus of cingulate gyrus, isthmus of cingulate gyrus. And I forgot to mention this one here. Here we actually have another one. So 13, I'm gonna just add 14 here for us to remember. Here and here. These two little ends. Okay, but let's move on. So that would be the occipital and the temporal lobes. So all the gyri from these two lobes. Up here that we have the frontal lobe, we have 12, 13. So 12 would be the gyrus rectus, That's one way to say it. Another one is actually simpler than that, straight gyrus. Straight gyrus. People tend to use both of them. So the gyrus rectus and the straight gyrus, or the straight gyrus. So that would be the name of this structure. And 13, that would be actually the name is just like the sulci, so orbital gyri. Orbital gyri. Gyri because there are a lot of them here. All of them actually have the same name. Okay, so here we have all the sulci and gyri of the inferior view of the cerebrum. Just for us to finish here, I want to show you guys a couple of functions that we can analyze here. Actually, it's going to be very introductory, but we can see some of the functions. For example, one of the main things about this area here, that is actually, it is the frontal lobe, but more specifically, it is the prefrontal cortex of the frontal lobe. It's actually, so I'm gonna just make a huge dot here, kind of a stain, and so here and here. Okay, so I'm gonna just make it on one side. It's actually controlling the inhibitory control. So one of the main functions of this area is actually inhibitory control. What does that mean? Inhibitory control means that whenever you wanna do something and you have kind of you are struggling to do something because you gotta stop the automatic behavior and actually behave in some other way, you gotta stop this automatic behavior. So which means that you have to inhibit this behavior, and that's one of the functions of this area. So help you to inhibit an automatic behavior in order to behave in another way. So we can also call this structure here, or the function of this structure, the impulse control. And of course, like if you damage this area, we're going to have a very hard time controlling your impulses or inhibit this automatic behavior. So that would be one of the functions of this area. So I'm going to just add an A here, A. Inhibitory control. Inhibitory control. Okay. Another one that we can tell here. Actually, I just mentioned before, but here and actually here, I forgot 14. So 14, that's called uncus. Uncus. That is also related to the olfactory functions. So here as well. Actually starts all the way here, comes down, but those are the main areas of the brain that are actually the olfactory function. So B. Olfactory. Olfactory functions. And other than that, we can analyze, for example, this structure here. Here, that would be C. That is related to memory. Memory, but not memory in general, but specifically one kind of memory that is related to verbal memories, which means that are memories that you actually can talk about, that you can tell other people. So in neuroscience, that's called declarative memories. So memories that you can declare, that you can talk about. So for example, what I did this morning, what is my name, everything that I actually know how to describe is declarative memory. That is also not just related to these structures, but also related to these structures of the brain. So the parahippocampal gyrus and also the hippocampi, both hippocampi and both parahippocampal gyri, here and here. Okay, and just for us to finish, I just want to highlight another region of this view, that is this one here, both hemispheres, that gets part of the fusiform gyrus and the lingual gyrus here, that is responsible for recognizing patterns, especially visual patterns, in especially very familiar patterns. So, for example, there is a condition called prosopagnosia. So that would be D. See? D. Prosopagnosia. Prosopagnosia. That is related to a condition where the patient can't recognize familiar faces, not even his own face. So, but that's very interesting because it's more related to familiar faces. So he can recognize, for example, if somebody is a girl or a boy, but he can't recognize, he has a very hard time recognizing his own, let's say, mother, father, brothers, sisters, I don't know, like very close friends, and even his own image, for example, in a mirror or pictures. And this is called prosopagnosia. Prosopagnosia comes from Greek, so prosopa in Greek means character or face. Gnosia comes from gnosis in Greek, that means recognition or perception. In A, no. So you can't recognize faces. Prosopagnosia. Okay, guys, so thank you so much for your attention. If you have any question, just let me know, and we can try to help you guys out. So thank you so much.